discuss about the degree of freedom. So this is also important in statistics and also econometrics. So you see, that when we do research, we must find the level of significance, whether the estimates are significant, at what percentage that we have already discussed, and at what degrees of freedom. So today we'll discuss the degrees of freedom. So it tests the reliability of estimates. So the reliability of the estimates is tested by degree of freedom. So it is, the topic is mainly on understanding. There is no mathematical wizard. So it is simply understanding. So reliability is tested through degrees of freedom. We can select various values to form set of such values. Suppose we have the function. So y is the function of x. Y is the function of x. So we will have the x values and we will have the y value, values of the dependent variable and values of the independent variable. So the values, suppose there are 30 observations. So x1, x2, so on up to x30, we will have 30 observations, 30 values. So it may be sample of values of variables. So x1, x2, so on up to xn, n number of observations, as you say x30, there will be values, there are 30 values. Or it may be a set of deviations of n values of variables from mean. So either it will be just the values or it will be the values of deviated from mean. So x1, we know x bar, the mean of the x series, sorry, mean of the x series. So x1 minus x bar, mean, then x2 minus mean, x3 minus mean, so on up to xn minus 1 minus mean, and ultimately it is xn minus mean. So we can find out this way also from, so it may be a set of deviations from of n values of variables from mean, or it is the sample of values of variables, simply variables, and is simply mean deviations. All values can be freely chosen, freely to choose all the values without reference to other values within the sample. So all the values, there is free hand. There is no any restriction, or there no need of any reference, earlier reference to choose a value. That x5 we have chosen because x4 is, or x4 was chosen, not like this. So there is free hand to choose all the values. Then the n times consists of free choice. So n times the number of observations. So if we have n number of observations, so in all n number of observations, we have free choice. There is no any restriction. Then we have n degrees of freedom to choose. So then we call that we have n degrees of freedom. So n observations are there. If we have no any restrictions, we can freely choose, then we say it is n degrees of freedom to choose. From n values of x, set of n derivatives can be formed from mean x. So mean, we know x bar is equal to summation xi by n. So x series we sum up, then divided by number of observations. As I say, suppose there are 30 observations, and in all 30 observations what is the sum of x? Sum of those values divided by n, this becomes the average. Now again, if we see the mean deviations from each values of x, about x1, x2, so on, there will be n number of deviations. So if we sum up, it must be 0. If we know n minus 1 of the derivations, the nth is automatically determined. Suppose 1, 2, 3, so up to n, then n minus 1 means this just previous one. Suppose observation is 36, then n minus 1 is 35. Okay, so if we know n minus 1 of the observations, then nth is automatically determined. You will see that. So there is example. There are suppose 4 observations and 3 of them are 5, 3, 2. So if we follow this, how the mean deviation will be 0 from this, then we will find that if we subtract 4 deviation from mean, then it will be 0. So there will be little exercise. Now if you do this homework, then you will find that if we put x, that means 4, then it is then it will be 0. That means 4 is more, and we have to subtract it. Then our deviations, sum of the deviations will be 0. Now, in any set of n deviations from mean, any set of n deviations from mean, one can be chosen arbitrarily. So the nth must assume a value so as to bring it to 0. As you have seen, that if there are n deviations from mean, one can be chosen arbitrarily. The nth must assume a value so as to bring it to 0. So we will have to choose n in such a way so that the value of the sum of the deviated value is 0. We can choose only n minus 1 items of our set. Only n minus 1 item of our set. So only one. So in the set we have the 4 observations. So we can choose only one. We cannot change earlier others. So we can choose only n minus 1 items of our set. We have n minus 1 degrees of freedom. So when it is satisfied, so after adding the 1 or subtracting the 1, our sum is becoming 0, then we say we have n minus 1 degrees of freedom. So this is the concept. We have n minus 1 degrees of freedom. Now why this n minus 1, why not n degrees of freedom? 1 degrees of freedom is lost in computing x bar from the sample. So it is said that 1 degrees of freedom is lost in computing x bar from the sample. So that's why the remaining is n minus 1. So this n minus 1 is the degrees of freedom. So when you examine the estimates significance level, then we should also mention the degrees of freedom. So this is significant. B1 estimated is significant at this much level of significance, and at n minus 1 degrees of freedom. So this go through this, and this is also important in relation to testing of hypothesis. So thank you very much and for watching, and please subscribe and share so that it reaches the students who need this. Thank you.